Hey everybody, I'm the math tutor and today we'll be learning about the real number system. This is my first video and I hope everything you hear today is informative, enjoyable, and educational. So, the real number system. Let's define what a real number is. A real number is essentially any number. It could be positive, like positive 6, negative, like negative 3, a fraction, like 3/4. It could be a square root of 9, could be like a number with an exponent, like 3 squared, or it could be pi. And the real number system is divided into subsets. And as you can see listed here, I show 5 different subsets of the real number system. So the first one is the natural numbers. They are the natural numbers, or you can call them the counting numbers. And essentially what they are is when you count, so 1, 2, 3, 4, 5, those would be considered the natural numbers. Below that you see we have the whole numbers, which look very similar. The only difference between the natural and the whole numbers is that the whole numbers include 0 and any of the natural numbers after that. The integers is, you can see it builds up from the whole numbers, is all of the numbers included in the whole number subset, and you include the negatives. So the ellipse at the beginning and end would be considered a continuation. So -5, -4, -3, and continues upwards up until what we would consider infinity. Our next one is the rational numbers. And a rational number is any number that can be expressed by the ratio a over b, where b cannot be equal to 0, because if you put a 0 in the denominator, that becomes undefined, and as we all know, you cannot divide by 0. So a couple examples. So 5/4 would be a over b, where a is 5 and b is 4. 6, where a would be 6 and b would be 1, so 6 over 1 is the same as 6. 2/3, and I also wrote -6/8 because it could also be negative. Now, where it gets tricky are the irrational numbers. Irrational numbers are the numbers that cannot be written as a ratio of a over b, and they have an infinite non-repeating decimal. So the most famous is pi, 3.14, and 15926, etc. That's considered irrational because it has a non-repeating infinite decimal. Same, another example, I couldn't do the square root symbol on, I'm using paint, but the square root of 2, which is 1.41421, and if you use the calculator, you would see it goes on forever. I showed an example that is not irrational that some people may consider would be, so 3.565656. What makes it not irrational is that it has that, it doesn't have that infinite non-repeating decimal, 5, 6, that continues on and on and on. And that would be considered rational, because that's, if you converted that to a fraction, I don't really know what it is, I didn't look into it, but it would be a number expressed as a over b. So that concludes my lesson on the real number system. I hope you learned something and thought it was interesting, and enjoy your mathematical journey.